Okay, let's see. I've been working a lot today, so okay. Hopefully I keep my concentration here. Okay, so why don't we there's a couple of problems I want to talk about. So there was one that was actually in the review sheet, and there was one that was in the review sheet, and I said to skip it because it involved anything involving a two-dimensional array. So why don't we do one of them right now, and then I want to do another one which is not in the review sheet. I'll make sure this file is online, and so the first method I want to talk about is a get largest row length. And so can everyone see that? Or you should at this point be seeing Eclipse, and you should see a file called test, and it has this the header for a method called get largest row length. And if you see there in the main method here, and then I kind of then I commented out that other method sub. We're gonna write another method called sum string lengths. And so let's see here.
Professor, can I find these the files on the lecture?
Okay,
file?
this file is not online.
Oh, cool. All right.
Oh, sorry, I guess I was about to sneeze or something. Okay, so anyway, well, I'm here by myself. I guess that's good. Okay. So let's see here. Okay, so I will put this file online tonight, okay? I kind of did this on an impromptu in my last class. Yeah, so there is okay, so first of all, this came from this, okay, let me show you something. This came from, let's see here. This should be on so there's in Canvas, there's there's a folder called for each. Here, let me see if I can show you. Let me just minimize this. Now, am I in Canvas? Yeah, so let me just close this. Yeah, everything's kind of in the way here. So where do I, let me just move this. Let me close this. And then, yes, you go to files. And so where did go to lecture 3. And no, for each. This is for the for each loop. Go to for each. And so that should be files lecture 2. I think I even might have put a module up there, and then review questions. And I think this is one of the review questions. And I have the solution there too. Okay. Okay, here. So review questions for chat. And I think this is one of the ones at the end. Yeah, get largest row length. So that's the one that I'm doing. And I'm assuming that X isn't null and that all rows of X are not set to null. Okay, so everything has an actual address. So, so that's the problem I'm doing right now. And let me just minimize. Hello. Okay, okay, that's not what I do to minimize. Okay, so I want to bring up Eclipse again. So now I think you should be able to see Eclipse. I think I opened up Zoom in such a way I can move from application to application. So everyone should be seeing Eclipse right now. So I'm going to do that problem from the review sheet, get largest row length, and then I'll put this, and then there's an extra bonus problem that I have that I'll put online tonight. And then, okay, what the goal is to, I think you could do this, probably, maybe this might be kind of an intermediate problem for Math 130, but what we're going to do is we're going to use this for each loop. And so here's an example of an array. So the important thing, what is this thing here? Well, Eclipse gives all these warnings. I never, why is this here? Okay, so anyway, Eclipse, what are you trying to tell me? Okay, so on line 17, you should see a two-dimensional array. And then remember, the thing about it, remember in Java, there really is no such thing as a two-dimensional, even though I use that term, everybody uses that term, it really doesn't exist. In Java, we really just have one-dimensional arrays. But what you can have is an array of arrays. So a two-dimensional array, to me anyway, it's just a collection of 1D arrays. And if we understand that, then I think we really understand arrays. So so we can actually have like an array of basically anything. So we have an array of arrays, And so here you see that first one-dimensional array, the length is 3, you know, has the numbers 1, 4, 5. Then in line 18, we see an array, 111, -7. That's our second array, the length is 8. And then the third array is kind of sad, only has one element at 3. And then the very last array, 8, 20, 14, 3 is length 4. Okay, so and so each one of those arrays, yeah. So basically, a two-dimensional array is just it's like a set of one-dimensional arrays. And what we're going to do is we're going to write this method, and we're going to pass x, the array that's defined in line 17, to get largest row length. And I just use the same parameter name, though, that you don't actually have to have that. But okay, so the idea is, okay, we're going to get the largest row length. So we're returning an integer. So what I do usually, you know, okay, so here's the name of the method. You look to the left, and what do you see is the data type we're returning is int. So let's just declare a local variable, an int, and let's just say, let's just assume that the largest is 0, that every row has length 0. Can't get any smaller than 0. That's the smallest possible value. And then we're going to return largest. We're going to return largest. So now at least it compiles. Okay, now it at least compiles. Okay, so we're like 8% of the way there. Okay, so it compiles, but it doesn't really do, well, it only works for arrays. It always returns 0. So if all your arrays have 0 elements in it, it's great. Okay, so now so here's the important part to understand. So let me just actually, I'm going to put this part of this. So there's your part of the for each loop. We haven't finished typing the whole thing in. Do you see how I have that? Okay, so why my computer seems really slow. Okay, maybe it's just I'm being impatient. Okay, so we have the part. So far we've typed in x. Okay, but what is x? We look at the parameter, it's a two-dimensional integer array. And what we just mentioned is a two-dimensional integer array is really just a collection of one-dimensional arrays. So remember, what you type on the left side of the colon operator is the data type that's being stored. X is a collection. So X is a collection of 1D arrays. Okay, so we say the data type of the collection, so that's int, that's the data type. And then we have to, have some placeholder, some variable name that represents each of the, because we're going to iterate. So how about just 1D? Something clever, something really clever like that. Okay, so, and the thing is, we don't have to look at the individual elements of the array, right? Because every array has a property called length. So that's one of the things that we have in Java. We automatically know the length of any array with one of our favorite properties in Java, the length property. And so, okay, so what we'll do is, okay, so if we find a length that's larger than largest, we update largest. Okay, so for every 1D array, so let me type this again. So for every 1D into, that's not the, I don't want to use the variable name, 1D int array in X. So for every 1D int array in X, okay, so if 1D dot length, see that's the length is greater than largest, let's just update largest. So the first time, so the first time, so the first time, in the first iteration, and we're going to pass an X. So for our problem, so the first time, 1D, oh, how can I say this? But okay, so here, I'll just say this, 1D equals this array, first iteration, right? Because that's actually what, right? Because that's what this variable 1D, we're passing in this array. What we're doing is we're passing in the address of the 2D array. And the 2D array, and that address tells us where all these 1D arrays are located. Really, it's just an array of 1D. Really, what's actually stored in this array X23 It's an array of addresses where every address points to a 1D array. Refers to a 1D array. So the first time 1D is this, and so I'll just type in one more time. The second time 1D equals this array. Let's see if I can move this up. Maybe I'll move it down. See, there's going to be 4 iterations, right? So forth here. So I can just cut and paste. So that's the idea, is that 1D is just going to move from 1D array to 1D array. And there's 4 iterations altogether for this particular example. So that's because it has 4 rows. And if you look at the rows, so the length is 3, 8. Oh, 8. Okay, so it's 3 plus 8 plus 1. What is it? That's 12. And then it shows it's 16. I think oh no, I'm sorry. I'm not adding the lengths. I'm trying to find the largest length. The largest length is 8, right? It's the second array right here. The length is 8. So let's just run this, and here, let me comment this out because it has we'll get to that later. That's for our second example. So let me just comment all the output from that. So largest length is, okay, so now we've got our method, and that string ARR array, we'll use that for our second example. Okay, so we should get 8. We're passing in the array that's defined at line 23, and we're going to find the largest length. Oh, largest length is 8. All right, it's pretty wild. And then this is where I am. Okay, and then you know, it all depends. Let's say I put a lot more data in here. You know, 0, 9, 11, 13. I don't know, -2, 100. Is it more than 8? Because it's 4. It's exactly 8. How about, I don't know, 18 and okay. So I think now it has 10. Now it actually, so that now the third array has length 10. So it should be, see, 5, 8, yeah. So now that third array has 10. Okay, so first length will be, we go through this method, first largest will be 3 because 3 is greater than 0. Well, 8 is greater than 3, so then largest is 8. 10 is greater than 8, so then largest is 10. And the last one, the length is 4, so the largest still stays 10. So you do 4 iterations. Now it should be 10. All right. So this is an example of a for each loop with a for each loop for a 2-dimensional array. And you can see here what might be is kind of interesting, or maybe, you know, if you haven't done it before, I think it might be confusing. How do we write how do we loop? You know, in Math 130, we use those nested for loops to loop over a 2-dimensional array. How do we loop over a 2-dimensional array with a for each loop? And we just have to recognize that the 2-dimensional array is a collection of 1D arrays. And if you can understand that, then I think you have a really good understanding of arrays. So I think the for each loop really forces us to understand, you know, how these 2D arrays, how arrays work. So any questions before I do the next interesting example, the bonus problem? Before we do the bonus, yeah, see, come here in the evening, and like I got this great extra new problem for you. And what I'd like to do, if there are no questions, but just call out anytime. Okay, so this one's going to be a little bit different than the first than the method on line 4, get largest row length, because get largest row length didn't involve a nested loop. It's just a single loop, because we're not looking at the individual elements of the array. Now, one of the things that you have to do in the assignment is, well, actually, you don't have to use a nested for loop for it, but I think it's not that hard. It's like a get sum method, which it might even be in that review. I have like a Java review folder, and I think there's a folder on 2-dimensional arrays. I mean, you know, writing a for loop to find the sum of all the elements in a 2D array is a pretty classic problem. You know, and I'm sure we did, at least I presented it in Math 1. I can't remember everything I did in Math 130. But what I want to do now is we're going to use a nested for loop. And so what we want to do is find the length of sum of the length of every string. So let's look at line 31. Do you see how I have that two-dimensional array, or we have that two-dimensional array? So the first array is like cat, dog, door. See, so remember, it's a two-dimensional array of strings. So really, it's just a collection of one-dimensional arrays. So for each loop, the for each loop is meant for collections, where we iterate over every item in the collection. Okay, so the first time, you know, the for each loop will look at that first array, and then the second array, building, school, 2 and 2, and then the third iteration, it would look like blue and orange. Okay, so my comments assume that my counter variable is S, so we'll call it S. Okay, so we're finding a sum, or we're going to, you know, we call this method. Well, we look to the left, and it says, oh, we're going to return an integer. So basically, it's the contract with the user. It says, you call this method, I promise you, you'll get an integer in return. So, and we're finding a sum. So I think any methods that find sums, I think sum is a good variable. So usually, typically, you initialize it to 0 and then return sum. And now our method compiles. Okay, the compiler's happy. The compiler does not care if we're returning the sum of all the strings. That's human. Humans care about that. And the compiler is just happy because you're returning an integer. Okay, so and now let's use a for now, and it's really short. Let's use a for each loop. We're going to have to use nested for each loops, because what we want to do is we want to look at we're going to have to look at every individual string. We're going to have to look at cat, dog, door, and building, and school, and 2. So when we get a one-dimensional string array, we're going to have to look at the individual strings. Okay, so let's just, okay, so for, and so that's the name of the array, it's strarr. Okay, so remember, so str, this, oh, I said it right there, so I'll say it again. So I'll just repeat my comment. str is a collection, I guess I like saying that, it's a collection of 1D string arrays. Okay, so for every, so it's a collection of 1D string arrays. So what do we put to the left? So the collection name is called strarr. It's a collection of 1D arrays. And to the left of the colon operator, remember we put the data type of the elements in this collection. And the individual elements are, it's an array of strings, right? And we'll call it S, so it can correspond to my comment. Okay, so for every string, so for every one-dimensional 1D array of strings S. Okay, so hello. Okay, let's see here. I'll write it above. Okay. For every 1D array of strings okay, so that's basically what we're doing. So the first time, right, I'm down there on line 37. This, I mean, that's the main method. And so, but we're going to pass ARR to this method. So the first time, S would be that array just containing cat, dog, and door. And in the second iteration, it would be the array containing building, school, 2 and 2. And then the third iteration, it would be the array containing blue and orange. Okay, so I have a visitor here. Okay, okay, so, okay, but we're gonna need a nested loop. Okay, so now for every string, S itself is an array, a 1D array, right? S is a collection of string values. So S itself equals a collection of string values. So S all by itself is a collection of string values. So for every string, I don't know, I'll just call it, for lack of imagination, T in S. So for every string T in S. S is a collection of string values. So the outer, so notice the dimension is going down. The outer, is it mad at me because I'm not doing this? Okay. Okay, so look at, so we now have this nested loop. So notice how the dimension goes down. The outer dimension, the outer loop it's an array of strings, and the inner loop is just an individual string. So I know sometimes students get, they have a hard time remembering that. Okay, so STR is a two-dimensional, and STR is the parameter is a two-dimensional array, and then when we do the for each loop, we have a 1D array, and then the inner loop is just an individual. It's just an individual element in the 2D array. Okay, so now all we have to do is, what's the name of our? Oh, I guess I didn't. Oh, I didn't mean to do that. Okay, so now let's just add on the, let's build up this sum here. Okay, so T actually is a string. It has a length property. And that's, whoops. And that's all there is to it. So, and you can see it's really not a lot of code. And once you kind of get from, once you feel comfortable with this, it might be hard at the beginning because it does look straight. I mean, if I was looking at this for the first time, I would have a hard time with it. I think once you get the hang of it, the thing is, students, when you're dealing with for each loops, just remember, just resist the urge to use indices. Indices and for each loops do not go together at all. It's like, it makes us sad when we do that. Yeah. I feel sad when I see it. Okay, let's put it that way. Yeah, so the indices are for the kind of for loops we learned in Math 130. Okay, so and that's all there is to it. So like let's say we pass this array ARR to some, we pass this ARR in line 40 to some string lengths. So the first time T would be cat, and then it would be dog, and then it would be door, and then we would be end of the first iteration, and then S would move on to the next array of strings, and then T would be building, school, 2 and 2. Okay, we're done. Then S moves on to the next array, and then T is blue, and then T is orange. Oh, then there's nothing more to go to. We're done. So why don't we run this, and let's see. Then I'll let you maybe, it's kind of a critical thinking exercise. You can add up all those lines in your head. Okay, and I did it earlier today and got it wrong. Okay, so one of my calculus students is here too. That probably doesn't lift his confidence. Okay, Java application. Okay, so let's just run this. Okay, oh, I'm still doing, I didn't print out, sorry students, I didn't change the output. Largest length is 10. Okay, so I just want to see the output for here. Okay, so can I do this? Yeah, okay. Now let's run it. So in line 44, we call the method and we pass the array ARR, and we're assigning the output to that variable sum, and then and then we print out sum in the print line statement on line 45. $39 characters if you add up all those strings. Okay, so I'm going to take because I know the first array is 10, right? Cat 3, 3, and 4, and the last one is the last one is 10. It's blue is 4 and orange is 6. Yeah, so that's 10, and then now the middle one we'll skip. Okay, but anyway, any questions on that? So students, I will post this online, but I think I like these two examples. They're a little bit different. So the first one, we only needed we did not need a nested loop, right? Because every individual array has a length property. There's no reason to look at the individual elements of the array. Whereas the second one, we did have to look at every individual element. And that's basically how it works with these two-dimensional arrays. You pass in a two-dimensional array, the outer for loop of the for each loop, the outer for each loop, it's a 1D array. And then the inner for each loop is just the, the individual data. So it goes down in dimensional, 2-dimension, 1-dimension, 0-dimension. So, so any questions about that? And I know you may have to try that or just kind of, Ernesto, go ahead.
I have a question. I thought that you said we couldn't, so for each loops, I thought we were only able to run the data and not get like the sum of an array.
Oh no, you can get this. You can do any. No. You can do that. What we can't do, we cannot change the values inside the array.
Oh, so we can't update the variable.
Are fixed. So we can do read operations. We can do like read operations, and that's what we're doing. Is like, okay, so I'm getting the first time like T is cat. Okay, well I can get the length of cat, but I can't change cat. I can't say, okay, let's change this array element to like, I don't know, book. Something like that I can't do. You could do that with like the kind of for loops we learned in Math 130. And you can, the other thing with for each loops, you can't skip values. So you're gonna, there's 3 1-dimensional array, like on line 40, there's 3 1-dimensional arrays, 3 iterations. So and then like in these inner loops, you're forced to, the number of iterations is equal to the number of individual strings in the array. But yeah, as long as something you can't do is right. And anytime, and if you need an index at any time, let's say, I want to find the index where this particular value is located. No, you can't. And then you have to go back to our Math 134 loop. But does that help, Ernesto?
Yeah, it does. So, okay. And you said that the number of iterations are the number of strings inside the array, right?
It's the number of elements in the array. So whatever the data type is, it's the number of elements in the array.
So for string array equals cat, dog, door, that's 3 iterations right there, right?
Right, absolutely. And if we added another string, it would be 4.
4. All right, got it.
Okay. Sure. Okay, we got any other questions on for each loops or? Okay, they're kind of fun. You just have to try them. And yeah, and then the assignment, the first 2 methods have to be done with a for each loop, and the other ones it's up to you. Some of them I think there's one where you're looking at an index, and you can't use a for each loop for that. And students, if you have any questions, I really encourage you to start as soon as possible. And just if you have questions, if you're running into a roadblock, just send email to me, but attach your Java file. Just attach the whole thing, and I'll do my best to help you. So students, should we get on to the main topic? What we're all here, what we've been waiting for the host. No, actually, this is not the most. This is a big step. I would not teach this. I think I used to Math 130 I was a little crazy one time in Math 130. It used to be a 4-credit course, and I think I did actually. I can remember teaching what I'm about to teach you. Now I feel a little guilty about it. It was probably was too much. Okay, so I'm going to close I'm going to stop sharing here for a minute, mostly because I can't see the bottom of this. Oh, no, here it is. Okay, so I don't know if I need to stop sharing here. I'm just going to close Eclipse. But if I close Eclipse, does that mean I'm not sharing? Well, you'll still be here. I mean, I'll still be on Zoom. Okay, so yeah, save selected. Oh shoot, I shouldn't have closed Eclipse. Okay, well, I'll open it up. I'm gonna have to open it up again. I wanted Eclipse. No, we need it for our second example. Okay, we need it for, I'm gonna need it again. Okay, so I'll probably stop sharing at some point. I'm gonna open up these PowerPoint slides and we're gonna go through those. And when I need to open up Eclipse again, I'll just stop sharing and then open up this up again. Okay, so close. So now what I wanna do is, there's this folder called, where is it? Okay, so Oh, interfaces. Still haven't created the module yet. Okay, so let's look at this. Okay, so there's this file called interfaces PDF, and interfaces really it's surprisingly simple. It's not like there's really not a lot to it. The thing that I think that makes interfaces interesting, how can we use it properly? It's just a way, to me, interface is a way of extending the language, imposing some kind of standards so that we all, it's like system array copy. You know, we don't need system array copy to copy the contents of one array to another, but it just kind of standardizes it. So every Java programmer is doing it the exact same way. And then it makes it easier when you pick up someone's code, when you read code, oh yeah, I do that all the time. You know, it's just like, I always think, you know, like right now in my hand I have a pen. Let's say we all had our own, let's say we all made up our own word for this. It's like, wouldn't that be kind of like hard to communicate if we just made up our own words and then I go, what is your word for this? You know, it'd be kind of hard to communicate. So we just all agree to call this a pen, and then, you know, it makes the life a little bit easier. And interfaces are the same way. So the one thing we're going to need to do in, because this is an algorithms course, in a couple of weeks, you know, maybe like week 5 or something, and we have plenty of time to go through all the important algorithms. Because I know I'm doing a lot of kind of like non-algorithmic kind of stuff right now. But we definitely have time to do all the sorting and the searching and maybe even a little bit extra. And maybe go through linked lists. Yeah, I have a visitor here. So, yeah, uninvited. Yeah, okay, so let's see here. But the thing about it, so one thing we're gonna have to do for sorting is compare, right? How do you sort? You have to decide what one is bigger than the other. You know, just like if we're sorting a list of numbers, we see like, well, you know, we see which number is the biggest and we put that on the right. If we were going to line them up from like left to right, we'd probably put the smallest numbers on we'd go from smallest to largest. We go in ascending order from left to right. But let's say, you know, we want to sort a list of person objects, you know, the famous person class, first name, last name, age. Well, what does it mean for one person to be bigger than another? And that's up to us to decide. There could be lots of different criteria. Maybe we just go in alphabetical order. Hello, that was okay. I think hopefully if I hold her, she'll stop it. Okay. You know, we can sort by, let's say, last name. You know, isn't it common to alphabetize by last name? Maybe by age, but maybe there's other criteria too. So maybe like we want to sort by grade point average or salary or something like that. Or there just could be lots of criteria that we could sort, you know, maybe like a list of person objects. Just like you go to Amazon, you know, you can sort by cheapest, or you can sort like a list of books by last name or the title. So there's a lot of different ways you can sort. So it's up to us to decide what it means for one object to be bigger than another. And that's kind of what interfaces standardizes this way of comparing. So that's the thing about interfaces. There's no, it doesn't necessarily, we could all come up with our own ways of comparing classes or comparing objects, but interfaces just gives us a standard way of doing it. So that way, you know, I can pick up someone's code and go, oh yeah, I can, you know, it does it the same way that I do. Okay, so much for that. Okay, so let's see what interfaces are all about. And it's really kind of short. And then we'll do some coding examples. So I'm opening up this file called interfaces, and you should see, now you're like in the middle of the screen right now. This Zoom, I never really had gotten, okay, maybe if I put you up there, okay, I'm putting the grid up there. Okay, so I've never, this Zoom, I don't know. I mean, it's great that we have it. How could we, you know, if we have to, can't talk and meet in person, but anyway, I'm looking forward to not using, okay, so anyway, interfaces, and again, not graphical user interfaces, just it's a Java interface. So at the end of this lecture, you'll know, okay, what is an interface? Then there's these two new keywords, interface and implements, and then how to write and use an interface. And it's really not that hard. And then an example where we use polymorphism, because interfaces are great for, you'll see what I mean by polymorphism. And then we'll learn about the comparable interface. And we'll use the comparable interface a lot in this course. So, okay, so she wants to go down here. Okay, so, interfaces allow us to impose the same behavior in classes that appear to be very different in nature. So like that's the example I keep using over and over again, comparing objects in the same class. And so we can, so even though like a string class and a person class and a book class, they're different. A string and I wouldn't get a string and a person confused. I wouldn't confuse a book and a person. But the one thing that we can do with all three of them is that we can compare them. We can compare strings, we can compare person objects, and we can compare book objects. And of course, it's up to us what it means for, these one object to be bigger than another. So the classes are different. They don't extend the same, it's unlikely that they extend the same, except they all extend the object class. But the interface is a way to define the same comparison behavior in all classes, the same kind of, the same method. We're gonna compare via a method, and interfaces imposes the same method. And so then when we write our sorting routines, we can just write one sorting routine, and we can use it with any kind of class in the world with interfaces. So we can write a sorting routine that sorts an array of book objects, or an array of person objects, or an array of string objects. So it's really quite useful. And so students, if you've never seen a Java interface before in your life, there it is. So, and that's everything. There it is. I don't need to say any more. I mean, see, it's that's what I look at it. If you're learning this for the first time, you think, well, what's the big deal? Okay, so instead of saying public class, notice that we're saying public interface. And this is the first time that you probably, all through Math 130, isn't the first line like public class book, public class person, public class homework one, whatever. Okay, so now it's different. This is the new public interface. Interface is a key word, right? Can't be used, which means it can't be used as a variable name, even though even though it consists of all alphabetic characters. And the thing that an interface does, all it does, it defines method headers. So do you see how I have like a method header string describe class? So describe class is the name of the method, and it returns a string, but it doesn't actually give the details for the method. Though starting in Java 8, there is a way of, you can actually, it's up to the user can actually, or the programmer can actually define a complete method in an interface. We're never going to do that. So there is that option of doing that, but it's not something we need to worry about. And I'm not going to talk about it. Okay. So we use the keyword interface instead of class, and we're actually not implementing the method. We're just defining the method header. Okay, so for right now, just think an interface defines a list of this class just has one. I mean, that interface just has one, but it could actually be several method headers. And here's the second. Students, I'm getting ahead of myself because I can't wait to get to the couple slides down. So notice that here, that method header doesn't have a return type. I mean, it doesn't have like a modifier. This is like public or private or whatever. Okay, by default, all method headers in a interface are public. You can't get any. Public is the most general of all, and so the slide online. I guess this slide there, slide 5 on page 3, is equivalent to this slide 7 on page 4. Now, I don't really care which way you do this. Now, some people I've heard, I don't know if I've actually ever met someone like that, but some people would hate this. Why? They'd say, well, it's implicitly public. You know that the method in an interface has to be public. Don't type it. Don't type anything you don't have to type. So what I'm saying is that this slide, the slide in line 7, this slide 5, they're absolutely equivalent. The compiler puts in public for, we don't see it, but the public will insert public there for us. And so some programs are hardcore and they go, well, that if you type that in, like on slide 7, if you actually type public in, it kind of gives the impression you don't know that you don't have to type it. I don't know, who cares? Okay, anyway. But some people are supposedly, I've already heard about it. I've never met someone who did it. And I'll be very compassionate if they do. Okay. Okay, so anyway, students, but now Okay, so we know how to write an interface, public interface, give the interface a name. Interface name starts with an uppercase character, just like classes. And the compiler doesn't care if it starts with an uppercase, humans do. And now so now what do we do with this interface? It's just a bunch of method names. Okay, so now let's look at that slide 8. There's that keyword implements, which I promised we learned how to use tonight. Implements is another keyword, meaning you can't use it as a variable name. It says public class test implements describable. So if you say a class implements an interface, that class must implement all the methods in the interface. So test implements describable, therefore, the test class must have a method called describe class. It must have this describe class method. So it's kind of a contract to the user. Like if you see this documentation, like you go, like usually, if a class is like all the classes you get with the Java development kit have lots of online documentation. So if you see in the online documentation that a class implements an interface, it's an advertisement. Oh, you're guaranteed that this class has this method. So any object based on the test class can invoke the describe class method. So now why is this so exciting? So, okay, so big deal. Couldn't I just have a describe class? I could put that describe class method in my test class without implementing describable. Yeah, so I guess I know on slide 10, that's what I'm saying there in describe 10. And so we're going to look at that. We're going to look at the example pretty soon. So I'm going to actually unshare for a second, open up Eclipse and share again. Okay, so what's the point of an interface? So, as I said, we could eliminate, where are we? We could eliminate implements describable. And that code would still compile. We could still put the describe class method in there. So what's the power of the interface? And you'll see the idea is that a parameter to a method could be an interface. And so that's the big deal about it. And that's where this polymorphism comes in. So I'm going to actually, for right now, I'm going to unshare just for a second, and I'm going to reopen Eclipse and share again. So of course, this is where I'm trying to stall, where I try to find Eclipse on my computer. Okay, so hold on, students. I didn't mean to close it. Yeah. Oh, here we go. It should be open soon enough. Okay, so I'm going to see any questions, though. So let's see. I think the Eclipse is opening. Okay, so or it's trying to open anyway. Okay, so I'm going to share the screen again. Oh, wait a minute, I have to go. I click on this and I go share. Is that okay? Do you see Eclipse or
it's
what happened?
coming up?
Okay, what happened? Yeah, I didn't quite expect that to happen. I'll be honest. Okay, so okay, here that was strange. Okay, it's strange for me. Okay, so I kind of came semi-prepared. Which for me it's pretty good. I'm I know this stuff. It's just I'm not. It seems to be slow. Okay. Oh, now it's better. Yeah, it seemed like it slowed down there for a second. I thought I froze there for a minute. Okay, so yeah, I'm just unorganized. I know this stuff. Okay. So now, students, there actually is this. If you go to the let's see here. If I close this, I'm not close. I mean minimize. So what happened here? Oh, here. Okay, so now do you see the PDF file again, right? So I'm going to close this, and do you see I have example for lecture? So I'm in that folder called Lecture 4 Interfaces, and then there's a folder example for the lecture. Why isn't that opening up? Okay, there it goes. Okay, so and then you see that yeah. So this is what I'm just right now I'm going to use those files right here. Okay. So let me open this up. So now you should see Eclipse again. And I have more files in this. Okay, so I have other files in there too. In but let's just look at this. So here we have describable, and here's the interface. And so this one, Let me just put this down here. Okay, so that's the interface. So that's not built into the language. So I wrote this. Okay, so, oh, you see I put public there. So yeah, so some hardcore programmers would look down on me, I guess. Okay, so then I think I typically put the public in. Okay, and now we have these other two. So now we have two classes that implement describable that I put online there. One is called S. Again, these classes are just, this is kind of a really silly example. It's just kind of meant to demonstrate how interfaces work. I'm not saying it's a really useful example. Okay, so now we have this class S, implements describable. So you remember, oh, implements describable. So you ask yourself, you either have documentation for describable or you have the actual code itself. So again, we go to describable. Oh, it has a method called describe class. So S better have a method called describe class. It can have other methods. It can have everything that we learned in Math 130, but it must have that method describe class that returns a string. And it does. And in this case, I just say it returns the string. This is class S. And then W implements describable. Therefore, it must have a method called describe class that returns a string. We're forced to do it. So let me just show you something. So if I just comment this out, I should get a red dot in line 2. Okay, and it says this type, the type W must implement the inherit abstract method. It's kind of a little, it says, the error message is a little confusing. Basically, it says I better have a describe class method in there. Okay, okay, in kind of a wordy way. And now that gets rid of the compiler error. So now I put that describe class method back in there. And it's all because I say implements describable. Implements describable is what is forcing us to have that describe class method in there. Okay, so now students, the highlight of, almost the highlight of today's class. How about one of the highlights? If we were like plotting this, it'd be like the excitement would be going like this. Okay. Okay, so yeah, so here we're getting to one of the high points of the class. Okay. Okay, so look at line 2. See, this is what I mean by polymorphism. Okay, so see how I have that method called display, public static void display, but look at the parameter. The data type is an interface. And see, I can pass an object for any class. I can pass an object to this method, to the display method, as long as the object comes from a class that implements describable. So remember, W implements describable. And then I have this bonus Z class that I added in the last hour. We'll look at that in a minute. Okay, so W implements describable, class S implements describable, and then I guess because I was enjoying this so much in my last class, I also added this class Z. It doesn't, basically you can add as many classes as you want as long as it implements describable. And so what's going to happen is the first time, so there on line 8, we call the display method, we're passing a W object. So what happens is that, so W, so that D, so the first time D will, so parameter D, oh, I have the cap on, okay. Okay, parameter D is a W object, or will be a W object. Right? And that's polymorphism. So this variable D, that parameter D on line 2, it changes its nature during runtime. That's what polymorphism is. It's when an object variable changes nature during runtime. So the first time, D will be a W object. And now on line 10, we're passing an S object to parameter D. So now parameter D will be an S object. And now parameter D will be a Z object, because in class Z implements describable. So that's the great thing about interfaces. This is the whole power behind interfaces. It can be a parameter. It can be a parameter in a method. And then you can pass any object whose underlying class implements that interface. However, do you see that variable D? We're restricted to methods defined in the interface. So remember describable just defined, remember describable only defined describe class. So we are restricted to the methods defined in the interface. But the one thing is, because class W, S, and Z implement describable, we were forced to define a describe class method. So let's just run this. And then we're going to look at a kind of the comparable interface. So is it running? Oh, no, not yet. Yeah, so first time it says this is class W. It's the string returned by the describe class method in class W. This is class W, this is class Z. And for class Z, I said for class Z, I said the describe class method returned I am a Z object. Yeah, but the important thing is that every time, the important thing is that for every time you call display, the true nature of the object, the true nature of D changes during runtime. The compiler thinks it's a describable variable, but at runtime, the runtime environment first thinks it's a W object, then it thinks it's an S object, and then it thinks it's a Z object. That's one of the great, that's the kind of one of the power behind object-oriented programming, is that we can do that. So we write this general method for an interface, and then, then we can write all these classes that implement that interface. But you only have to write the method one time. So any questions on that, students? So there's kind of, I think, so let's just review here. We learned the keywords interface and implements. We saw how to write it. We won't be really writing interfaces in this course. We will be implementing them. But here we saw, here's a simple interface. That's what it looks like. We saw a couple times how to implement it, like S. We implemented it, and we implemented it again. And then we also saw how to use the interface in a method. We learned how to use the interface as a parameter to a method. So now let's actually look at a kind of a widely used interface, and it's called the comparable interface. And comparable, and students, by the way, I just want to tell you, I encourage you all to stay if you want to, but I don't take attendance. And so I've been talking almost an hour. So if you have something you have to do, or you're getting tired, or you have like a huge biology assignment for tomorrow or something, don't worry, I'm not taking attendance. Also, your quiz is up there, and it'll be due Friday night. Okay, just wanted to let you know that. So anyway, where am I here? Oh, we're going to go. So I'm going to go back to, I'm not going to close this. I'm going to minimize this. I'm trying to remember what I'm going to do. Well, let's finish those slides. Okay, so I'm going to minimize this. Okay, so let's go back to, I need to go back to I think I closed this. So interfaces. So let's just look. I think there's a little bit more in this file, and then we'll just look at some code. Well, actually, there's a worksheet that we'll implement a couple of interfaces. And we'll implement the comparable interface. And I am taping this, I'll put this online. Okay, so students, this is where we left off at slide 5. And so, is someone talking to me? Okay, yeah, see you later. Okay, so a widely used interface is comparable. And we don't write this, students. So sometimes I've asked students to implement comparable, and then they actually write this code that you see right there. And that gets very confusing to that actually gets confusing to the compiler, because now there's the one that's built into the language, and then you have your own comparable, which one is actually, being used. Okay, so it's just like the string class. We use the string class all the time. We use it like probably since like on day 1 of, or certainly the first week of Math 130. But we don't actually write a string class. It's given to us. Luckily, we don't have to write it, because if we had to write all these classes, it'd take us forever. So you install the Java Development Kit. We get lots and lots of classes that we can use. And one of the classes we get is comparable.java. It's a compressed file and it's somewhere on our computer. And that's kind of the code. Oh, and students, notice that what does it have there? Our friend, the generic. See that in the diamond operator of comparable, and then there's the diamond operator T. And what's the parameter to compare to? It's T again. So what we're going to do is that we're going to pass in, when we write these, when we implement comparable, we're going to pass in T. T is a variable that represents a class name. So we're actually going to pass in a class name. And then whatever class T will do, whatever class name is passed in, T is replaced with that class name. Okay, so the parameter of compare to will be whatever, the parameter to compare to will be whatever class we passed to comparable. And you'll see an example in a minute. Okay, so again, the important thing about, students, what's the name of this method that we have in comparable? Compare to. So students, let's just get, so compare to is our friend. It's our new friend, not a friend that you didn't ask for maybe, but it will be our friend, at least as long as you're in Math 140. And that's the method we'll use to compare objects. So every Java program in the world uses compare to compare two objects. So this is what I'm saying. We add some kind of, it's a kind of a standard that's kind of imposed on the language. We can come up with our own method to compare objects. Like maybe my method is compare, and maybe someone else uses a method called compare objects, but it's not good if we're all coming up with our own method names. So this is just kind of a standard way that we're going to use to compare objects. We're going to use this method compare to. So all kind of Java programs who are good citizens use the compare to method. Okay. So yeah, and the thing is, we have to use methods to compare objects because we can't use, remember, I think I mentioned this last time, we can only use the less than or greater than operators to compare numbers. You cannot compare strings with less than or greater than. To compare two strings, you have to use compare to. Okay, so here's just an example of, let me go down to slide 14. And is this the last slide? And then we'll go back to slide 13. Okay, so what can I do with this? Okay, so let's just look at slide 14 first. And do you see how, and so remember, so we're going to compare, so just assume that object 1 and object 2 are objects from the same class. Like, so assume they're two string objects, or assume they're two person objects. Don't you think, just, visualize, just pick your favorite class and just assume object 1 and object 2 are objects from that class. Okay, so the object to the left of the period, or I'm not sure what that operator is called, the period. Okay, like object 1 period, or if they call it dot, I don't know. Okay, but so to the left of the period, that's the calling object, and then what's in the parentheses is the input argument. Okay, so okay. She's back. Okay. So if object 1 compared to object 2 is positive, it'll just mean that object 1 is greater than object 2, and that's not an obvious thing. It's just something that's kind of made up. It's a rule that we agree to. It's a rule that was made a long time ago, and now we all have to use. It's just like we all drive on the, I guess, on the same side of the road. That rule was made up a long time ago, but we all do it. Okay, so when we implement comparable, we have to, when we decide what it means for one object to be another, we just make sure that the compare to returns positive if we want the calling object to be greater than the input object, the input argument. Okay, so if compare to returns 0, it just means that object 1 is equal to object 2, and if object 1 dot compared to object 2 is negative, it just means that object 1 is considered to be less than object 2. So remember, for strings, the default value, the default behavior for, let's say we have all strings that consist of alphabetic characters of the same case. They're all lowercase characters, they're all uppercase characters. Then it's just, the closer you are to page 1 of the dictionary, the smaller you are. So like cat compared to dog would be negative because cat is less than dog. Okay, so let's see here. So now I have this kind of real live example on Okay, and I think this slide is on, this code is online. Okay, so public class circle implements comparable. Okay, so we're implementing remember the comparable interface just defines one method, compare to. So we're saying, and plus it requires that generic value. So when we go implements comparable, notice after implements comparable of the diamond operator, and what do we put in there? We put in a class name. And so it's always going to be the same. So if you see public class circle implements comparable circle, so you're going to see circle 3 times. The class name is circle. We wanted to implement comparable. Oh, inside the diamond operator is circle, and that allows us. And then the parameter to the compare to method is the same name as the class. So these two are actually going to see these two. What's in the diamond operator and the parameter to the compare to will be identical, right? See the t, the parameter, the generic variable is t and the parameter is t. So what's in the diamond operator and what's in the parameter type to the compare to identical, but you just want it to be the same name as the class. I mean theoretically I can compare circle objects to person objects, but that would be not very useful, I think. Okay, so the class name is circle, then the generic variable is circle, and the parameter is circle. Okay, so in this example, so notice I'm going this dot radius minus c dot radius. So this refers to the calling object. So this would refer to, so this always refers to the calling object. So like this would like object 1 is always to the left of the period. So this would refer to object 1, and then object 2 is the input parameter. And notice what we're doing is we're subtracting radiuses, or radii, I guess that's the correct way of saying it. And when is that positive? It's when the radius of the calling object is bigger than the radius of the input parameter. So and so when that's positive, that means that object, then the radius of the calling object is greater than the radius. Let me say it again, I'm stumbling over my words. Okay, so when compared to returns positive, it means that the radius, the radius of the calling object is greater than the radius of the input parameter, right? Because so this dot radius minus c dot radius is positive when this dot radius is greater than c dot radius. So basically what we're saying is the larger the radius, the larger the circle object. It doesn't have to be that way. That's just the way, that's our decision. Also, so notice how simple this is. It's one line, and all the method, at least as far as our quizzes and exams are concerned, if I ask you to write a compare to, you can actually implement it in one line. I know some students do it in more than one line. They start using if statements, and it's really unnecessary. You see, it's returning an integer. So if the radii are identical, then it returns 0. If the radius of the calling object is bigger than the radius of the input argument, then it's positive. If the radius of the input argument, if the radius of the calling object is less than the radius of the input argument, then it's negative. So the bigger the radius, the bigger the object. So now, why don't we actually just try this, and then we'll try one for a rectangle class. And this will be part of your quiz on, I'll ask you to, so part of your quiz, I'll just ask you to write maybe like a simple class and a compare to method. So I'm going to open up Eclipse again. Unless there's any, don't hesitate to ask questions. Okay, so where am I? Okay, so here, I think I added something to that circle class. So let me move this. Oh, this grid is bothering me. Okay, there's a way of doing it. So what happens if I go like this? Do you still see me? I'll assume that you do.
Your Eclipse and you.
Okay, so it's strange. I only see, I don't see, all I see is your square, Jose. Okay, so, okay. So you should see Eclipse, okay. Okay, so here's our class. This is the class that I had in the notes. But notice I also added a getter and a setter. And so this is the code. And notice that, yeah, so right now, the rule that I'm using is that the bigger the radius, the bigger how are we going to compare circle objects? We're going to say the circle object with the bigger radius is the bigger circle object. So now I have this code in circle.test. Okay, so I created 2 circle objects, and so one has radius 11, one has radius 7. So you should see that on line 6 and 7. And I'm going to call the compare to method. I know that no compiler, it definitely, well, we saw the code, it has a compare, well, it implements comparable, it must have that compare to method, right? We would get a compiler error if it didn't have that compare to method. And okay, so I call compare to, I save the output in variable D and I print it out. And so in this case, we're going to do another version of comparison. Let me just erase this. Okay. Okay. So, yeah, some of those comments below may not make sense, but let's just keep them for right now. So C1 is the calling object. So C1 corresponds to this, and C2 refers to the input parameter. Yeah. So C1, that calling object, the one with radius 11, refers to this on line 25. Okay, so now what's going to happen is it's going to return a positive value. It's going to return 4, right? We're just taking the difference of the radii, and it's 4. Okay, okay. It's not, the fact that it's 4 is not so interesting in and of itself. What's interesting is that it's positive. So that means, okay, so returns 4. So D equals 4. So that means that C1 is greater than C. So if we were sorting from like smallest to biggest, first we'd have, if we were lining up from smallest to biggest, we put C2 at the left and C1 on the right. Okay, but now the thing is, I don't have to, or we don't have to. We can create other rules, right? I can say, oh, the rate. Let's make up a rule that says the circle object with the smaller radius is actually the bigger object. Okay, so we'd want the compare to method to return a positive value if C1 has a radius that's smaller than C2. Or if C1.compareTo is negative, that means that C1 is less than, so C1.compareTo C2 is negative, that means that C1 is less than C2. Okay, so let's see what happens now. Let's go to circle. And I am just okay, so what I'm saying now is that we're going to create a rule where the smaller the radius, the bigger the circle object. So return. So now that all we do is flip this around. So remember, this is the object on the left. It's the calling object. So again, this is positive when the radius of this is less than the radius of the input parameter. And if the radius of the calling object is bigger than the radius of the input parameter, it returns negative. So let's just look at this. Okay, so now, so this is case 1. In case 2, let's just go right here. I guess my case 2. Now we should get -4. Okay, so C1 still has a larger radius than C2, but what I'm saying, the larger radius is the smaller circle object. So he returns -4. The fact that it's -4 is not interesting in and of itself. What's interesting is just that it's negative. So now the compare to method on line 9 returns negative. So in that case, that means that C1, the calling object, is less than the input parameter. And it's up to us to decide what it means for one object to be bigger than another. And that's what I'm saying. We can program whatever we want in the compare to method. So so that's really kind of we've gone through. I want to do one more example, but any questions right now? Any questions? Okay. Okay, and so let's do a rectangle. There's actually, so that was one of the problems in the worksheet for the, the interface has a worksheet. And now you'll use this for your quiz a week from today, something to look forward to. Okay, so there's no school on Monday. So though I'll be here to answer questions about anything or anything related to computer science or I guess calculus. Only if you're my even if you're not my calculus student, I can try. Okay, so it says we want to, I think I actually have the code written, but let's see here. So we have this rectangle class. We want to write a rectangle class, and there's two ways we want to write the compare to method. First, we want to write a compare to method that the rectangle with the larger area is the larger rectangle object. And then we want to write a method, then we actually want to write a compare to method that the rectangle object with the smaller perimeter is the larger rectangle object. Okay, so let's just look at, so here's my rectangle, I already wrote it. And I know that we all could do, well, hopefully we could all write the rectangle class from Math 130. Maybe I'd even put that on a quiz or something. But in this case, we wanted to implement comparable. So once again, students, look, the class name is, everyone should see a rectangle class now. Line 2. It's rectangle is the name of the class. Inside the diamond operator is rectangle, meaning we're going to compare rectangle objects to rectangle objects. And then the parameter in the compare to method is forced to be, it must be identical to whatever it is that you put in as the generic value. Okay, so the only thing interesting that we have to do here is I'm going to comment this out. So you can only have one return statement here. Okay, so there's only one rule for the compare to method. So we have these instance variables width and length, and so how do we compute the area for a rectangle? Isn't it just width times length? So this refers to the calling object, and R in this case is the input argument, and we're just subtracting their areas, and that's either negative, positive, 0, or negative. And it's all compared to 1. We want to know, is it returning a positive value? Is it returning 0? Is it returning negative? Okay, so so that this is on the outside. So we're subtracting off the input argument area from the calling object area. So when it's like this, well, like when this is on the left, that means that the bigger in this case, if the calling object has the bigger area, it's the bigger rectangle object. And that's the case when it'll return a positive value. Okay, so let's look at the, students, one thing you might be, sometimes students ask me about, some students don't, ask, or some students ask, do you see how I'm directly accessing the private instance variables like on line 13? See that? So line 4, width and length are private. Don't we say you can't directly access private instance variables? And now here I am. Did Skarpnik lie to me in Math 130? Well, only partially. So there actually is this rule in Java. Okay, so in this case, what is R? R refers to a rectangle object in the rectangle class. So the rectangle class itself can access the private instance variables of any rectangle object. And that's just a general rule. So if you have some class A and you have instance variables that are also of type A, so class A can refer to the private instance variables of any A object. So this line 13 is perfectly legitimate. And it's only because we have this parameter called rectangle R, and it's defined in a rectangle class. So we have direct access to the private instance variables. You don't need the get or the set method. In fact, I didn't even define them here, probably because I was rushing. Okay, so now our goal is, right, we have our compare to method. So the first compare version, the first exercise, okay, the bigger area is the bigger rectangle object. So here I have I think I still have everything here. So here we created 2 rectangles. So here the area, let's see, area is 40, and then perimeter, I think is 28. If I could spell perimeter. And then here the area is equals 20, and then the perimeter is equal to 42. Okay. Okay, so now we're going to do R1 dot compared to R2. So we're going to take the difference of the areas, right? Because right now that's what compare to does. It's taking and it's going to be the area of the calling object R1 minus the area of the input parameter R2. So it's going to be 40 minus 20. Okay, it's going to be positive, which means, so it's going to be positive. So that means object R1 is greater than R2. Oh, hello, what happens here? I'm just, yeah, Zoom is getting in my way. Okay, so. Okay, so D is 20 and then, well, I'll show you what that E is in a second here. So D is 20. So basically it's saying is R1 dot compared to R2 is positive. That means R1 is greater than R2. I just flipped it around. So in line 11, I'm going R2 dot compared to R1. So here we're subtracting the areas off. So here is R2 is the calling object and R1 is the input parameter. So now we're subtracting the areas. We're going 20 minus 40. We're getting negative 20. So this means that R2, which would make sense, is less than R1 because see, we're turning a negative value. So if R1 is greater than R2, R2 better be less than R1. Okay. Okay, so this refers to, this is case 2. I think the comment's confused. I'm just going to take this comment all together. Okay, so okay, so now let's, any question on that? So all we did, so notice how simple, again, when you're implementing these interfaces, notice how it's one line of code. We're just subtracting the areas. I guess it's the hardest part might be which one's on the left and which one's on the, you know, it's, but in this case, I want the this to be greater than the input argument. So we subtract off the area of the input argument from this. Okay, so now what I want is, so then there's this, the second problem was that, okay, that the rectangle with the smaller perimeter is the larger rectangle object. So I'm going to comment this out. So now I have this new rule. And now what it is, okay, so now we want this to be, so we want the input argument, okay, so this will be positive. So line 15 returns a positive value if the perimeter of this is less than the perimeter of the input argument. So in other words, if the perimeter of the calling object is less than the perimeter of the input argument, this is positive because now that this is being subtracted from. See, it's R minus, so it's the perimeter of the input argument minus the perimeter of the calling object. And that'll be positive when the perimeter of the input argument is greater than the perimeter of the calling object. It's kind of hard to say. You say it like 25 times a day. Okay, so let's just try this, students. Let's go back to test. So now, okay, here. So now let's see what we get here. So let's see. So R1 actually R1 will still be positive. R1 will still be bigger because it has the smaller perimeter. So, okay, so R1 will still be bigger. Okay, so let's just see here. Okay, so yeah, D is still 14. D is still positive. E is still negative. Right, because yeah, so in the second case, for that new rule that we just came up with, we're subtracting it's 42 minus 28. So it's the perimeter of the input argument minus the perimeter of the calling object. So it's 42 minus 28. So R1 is still R1 is still greater than R2. So and then again R2 minus R1 would actually in case 2, this is case 1. And then in case 2, what do we get? It's 28 minus 42, which is equal to negative 14. Yeah, so, yes, and then we go R2 minus compared to R1, yeah. We get, it's negative because R2 has the bigger perimeter. Okay, so, right, so let's just look at rectangle one more time to make sure that that's right? So it's so we're subtracting off, so it's the input argument perimeter minus the calling object perimeter. Okay, so the calling object, so the input argument perimeter is 28. The calling object perimeter is 42. 28 minus 42 is negative. R2 is less than R1. So again, but we can create all kinds of rules for determining what it means for one object to be bigger than another. So any questions on that? So I'll let you study that. Maybe I'll put up I'll put up the quiz from last year so you have at least one other problem to look at. So your next quiz, you're going to write methods involving for each with two-dimensional arrays, and you'll just write one of these classes. You'll implement the comparable interface, and so it'll actually be short. It'll be something like, I mean, I might ask you to write a whole class, but the compare to method will be short. Any questions right now? I might just close this. I might stop sharing then. So I'll stay here until there's no more questions.
I do have a question, but it's unrelated.
Was it about math?
It's about math and something else.
Okay, let me see if someone else has a question. So Ernesto, do you have a question?
Yeah, I have a question.
Yeah, go ahead.
It's about the interface. I think I just have to keep looking at it a little bit, but so the public interface and then the describable, is that always, do I always need to use a describable, or can I name it something else?
You can call the interface anything you want, but the only interface is, we won't actually be writing an interface in this class, we'll be implementing it. And for the most part, we're going to be implementing the comparable interface. So the interface that I talked about.
Okay, and so
it's very unlikely you're ever going to be
I'm
saying.
sorry, finish.
Oh, go ahead, Ernesto.
No, I'm listening.
Okay, so I don't think last semester I ever asked the students to write code where they're starting public interface. Okay,
Right.
so you're going to be actually but you will be implementing interfaces. For the most, there's two interfaces. For right now, it's comparable, and then there's another interface I eventually talk about called comparator. They sound almost alike, comparable and comparator. But comparator is for, like week 10 or something.
And the implement calls other classes, right?
Implements forces you, yeah, so when you go implements, it forces you to write the methods in the interface. So here, let me just share this one more time again. Oh, see you later, Air. So you see how, like in rectangle, do you see how can you see that? You should see on line 2, you see public class rectangle implements comparable. So we must, because it's implementing comparable, we must write a compare to method. See someone's sharing, someone's chatting with me.
She said good night.
Oh, okay. See,
So the rectangle class is gonna, no, I'm sorry. So we're gonna implement the comparable rectangle test, or that's where.
Oh, go ahead, say it again.
No, that's where I get confused.
Okay, so comparable is built into the language and it has a compare to method. Okay, and so comparable is defined with the generic. So we actually have to put we have to follow comparable with this diamond operator, and we put in the name of a class. So basically what this means is I'm going to compare rectangle objects to rectangle objects.
Oh, got it.
And then the
Okay.
public integer method at the bottom compared to rectangle
Yeah,
R.
you're forced to, see if I comment this out, let me just comment this out. I'm gonna get see how that red dot just showed up?
Yeah,
It's because we no longer have a compare to method. So when you say implements comparable, all it means is that you must have a method called compare to that returns an integer.
within within that one class, right? Within the implement class,
Yeah,
not the,
within the it's gotta be in the rectangle class.
okay,
Rectangle implements, see like here, like circle implements comparable. See now, see how the class names agree in the diamond circle, and then we have circle and the diamond operator. Oh, we have implements comparable. We better have this method public int compare to in the same class.
okay.
Does that help?
Yeah, that helps. And just one last thing. The diamond operators are used to are to, or I'm sorry, no. The inside the diamond operators is the type, it has to be the same class, right?
Yeah,
Or-
for we're implementing comparable, it must be the same.
Same.
Basically, it's saying, see what's in the diamond operator is going to be the same as this, is going to be, is going to be the parameter type. So what basically it's saying is we're going to compare circle objects to circle objects. See, I could put, I know it looks silly, but I could put string here. I'm going to get some compiler errors, but if that's string, then this also has to be string. It's these two are the same, but this is silly now. Now I'm comparing circle objects to strings. You know, I don't know.
Right.
No need to.
Yeah.
I don't think anyone does that. Okay, so
Because I remember in math 130, we would use the diamond operators for the arrays, right?
array list, yeah, for the array list, and it told us the type of objects that we can put in the array list.
Oh yeah,
That's
the
the first
type
time,
of,
that's the only time you use the diamond operator in Math 130. You're creating an array list, and like usually it's like array list of strings in Math 130. And it just says you're forced to put strings in that array. The array list can only have strings.
got it. All right. Thank you.
Yeah,
See
well,
you
just
next
write
time.
me, but if you have any other questions, write me, okay?
Yeah, of course. Thank you.
Okay. Then, Jose, do you have I'm gonna stop sharing here. Now, what's your question, Jose?
So,
Oh, wait,
Monday?
okay, I'm gonna just